In this video, we are going to look at different types of quadrilaterals, and we will look at the different types of angle theorems that apply to quadrilaterals so that we can calculate one or more of the interior angles and exterior angles of various quadrilaterals. In mathematics, a quadrilateral is a four-sided polygon. So it is a shape that has four sides. We can identify a quadrilateral as being a regular quadrilateral, and regular means that all of the side lengths are the same and all of the interior angles are also the same measurement. And so the only regular quadrilateral that exists is a square. We know that all of the sides on a square are the same length, and you can see that indicated here in this diagram by the double hash marks that appear on each side of the square. We also know that all of the interior angles in a square are the same. Every corner has a 90-degree angle. We also have irregular quadrilaterals. So for a quadrilateral to be irregular, it is because the side lengths are not the same length, or we could have angles inside the quadrilateral that are not the same value or not the same angle measurement. So you could have one or the other in terms of those conditions, or you could have both of them where they have no sides that are the same length and they also have no angles that are the same angle measurement. And so examples of irregular quadrilaterals would be a rectangle, a rhombus, a parallelogram, a trapezoid, and we even have a figure that's called a kite. So let's take a look at some of the angle relationships or theorems that exist for quadrilaterals. In terms of the interior angles or the inside angles, the sum of interior angles of a quadrilateral is 360 degrees. So if we take a look at the quadrilateral pictured on the screen, the interior angles are marked with lowercase letters A, B, C, and D. If we were to add up these four angles together, that would total or give us a sum of 360 degrees. A little bit different than what we know about the sum of interior angles in a triangle. In a triangle, the angles only add up to 180 degrees. However, in a quadrilateral, we're now looking at a sum of 360 degrees. For the exterior or outside angles on a quadrilateral, together they will also add up to 360 degrees. So going back to the diagram, the exterior angles are marked with the letters W, X, Y, and Z. And if I were to add up all four of these exterior angles together, they would also add up to 360 degrees. So the angle relationships for quadrilaterals are nice and easy to remember because both interior and exterior angles add up to 360 degrees. Although there are lots of different types of quadrilaterals, parallelograms specifically have their own angle relationships or angle theorems that can be applied to their shape. The first theorem or relationship deals with adjacent angles inside the parallelogram. Adjacent means angles that are beside each other or side by side to one another. The relationship states that adjacent angles in a parallelogram are supplementary, meaning that they will add up to 180 degrees. Now, adjacent angles in a parallelogram also happen to be co-interior angles. So let's take a look at this parallelogram that's pictured here on the screen. The interior angles of the parallelogram are marked with the letters W, X, Y, and Z. So what I'm going to do is highlight for you or outline for you all of the different adjacent angle pairs that exist in the parallelogram. And you're going to see that they are supplementary. So the first adjacent angle pair could be between W and X. So I'm just kind of highlighting around this set of adjacent angles in green. Now you can see that the section that I've highlighted in green kind of makes what resembles a C pattern. And if you remember your angle theorems, co-interior angles can be identified in a diagram by what we call the C pattern. So this doesn't explicitly look like a C, it's kind of like an upside down sideways C, but these angles W and X are indeed adjacent and co-interior. So what I know about W and X is that if I were to add those two angle measurements together, they would add up to 180 degrees, which means that they are supplementary. We can also see adjacent angles between W and Y. So I'm just highlighting around those angles. And you can see that these ones definitely do resemble a co-interior angle C pattern. And so the angles W and Y will also add up to 180 degrees. There is another set of adjacent angles down on the bottom of our parallelogram between angle Y and angle Z. So again, if I add together angle Y plus angle Z, those angles are also supplementary and should add up to 180 degrees. And finally, we have another set between angles X and Z. So these two angles are also supplementary and will add up to 180 degrees. With a parallelogram, the opposite angle theorem also applies. So opposite angles in corners of the parallelogram will be equal to each other. So for example, angle W is opposite to angle Z. So these two angles will be equal to each other. So angle W will be equal to angle Z. Same thing applies to angles X and Y, which are opposite to each other in opposite corners. They will also be the same angles. They will be equal to one another. All right, now we're going to take a look at some different examples on how to apply the angle relationships or theorems for quadrilaterals. In example number 1, we're asked to find the measure of the unknown interior angle. So if we take a look at the quadrilateral that's pictured, we have one interior angle that's 56 degrees, one that is 95 degrees, one that is 98 degrees, and we have an unknown angle here marked with the lowercase letter x. So we need to figure out what this angle is. What we do know about the interior angles inside a quadrilateral is that altogether they should add up to 360 degrees. So to figure out what this missing angle x is, we can simply just subtract the given angles from 360. So I've set up my equation and I've simply just subtracted all of the given angles from 360. So x would be equal to 111 degrees. In example number 2, we're asked to find the measure of the unknown exterior angle. So again, we are given a quadrilateral. They've extended each line segment outwards to make kind of a branch on each corner, and that gives us the exterior angles that are marked 50 degrees, 88 degrees, 105 degrees, and this unknown fourth exterior angle, which they've labeled as lowercase letter y. So again, we know that the 4 exterior angles on a quadrilateral should add up to 360 degrees. So to find this missing angle, I'm simply going to subtract the given exterior angles from 360. So I've set up the equation to solve for y, and if we perform the subtraction, y would be equal to 117 degrees. In our next example, we have a parallelogram. And I know this is a parallelogram because of the markings on my 4-sided shape. So these arrowheads that are given represent the direction of the line segments. So I have this line segment WX, which is marked with 2 arrowheads, and line segment VU is also marked with 2 arrowheads. So that signifies that these 2 line segments are parallel. The same would apply for line segment WV, which is marked with 1 arrowhead, and line segment XU, which is marked with another arrowhead. So these 2 line segments are parallel. We're asked to figure out the measure of the unknown angle. So angle V, if we want to call it angle V, is marked with a question mark. And we are told that angle U is 80 degrees. So remember, one of the angle relationships for parallelograms tells us that adjacent angles are supplementary. So we do have adjacent angles between angle V and angle U. So these 2 angles together need to add up to 180 degrees. So I've gone ahead and set up an equation. Angle V plus angle U equals 180 degrees. We don't know what angle V is, but we do know that angle U is 80 degrees, which I'm going to fill into my equation. And then I'm simply just going to isolate for angle V. So that means taking 80 degrees and bringing it over to the right-hand side. And so that's going to leave us with angle V equals 180 minus 80, and so angle V should be equal to 100 degrees. To finish off, let's take a look at a question like this. We have a quadrilateral, and each of the interior angles is marked with an algebraic term or expression. So we've got 3x, 6x, 4x, and x plus 10. Now, a question like this would simply just ask you to solve for x. So to do that, all we would need to do is set up an equation that we could use to solve or isolate for x. Now, because we are given information on the inside of our quadrilateral, we want to use what we know about the interior angles of a quadrilateral. And we know that the inside of a quadrilateral, all of the angles have to add up to 360. So if I take each of these terms and add them together, it must add up to 360 degrees. So we're going to take that knowledge to build our equation. So here's what your equation would look like. We've got 3x plus 6x plus 4x plus x plus 10. I've included brackets around this expression just so that I know that these two terms, the x and the 10, were included together in this corner angle. Altogether, the sum should add up to 360 degrees. Now, when you combine like terms on the left-hand side, we're going to simply just disregard these brackets. So that's going to be our next step. We want to collect like terms. So on the left-hand side, I see multiple terms that have the variable or letter x. So I'm going to start by putting those terms together. So 3x plus 6x plus 4x plus 1x is equal to 14x, and then I've recopied the rest. Plus 10 equals 360. Our next step is to collect like terms, so that means this positive 10 needs to come over to the right-hand side. So that'll leave us with 14x equals 360 minus 10. 360 minus 10 would be 350. And then to isolate for x, we want to divide both sides out by 14. 350 divided by 14 would give us 25. So the value of x is 25. To summarize what we've learned in this video, remember that in all quadrilaterals, all of the interior or inside angles will add up to 360 degrees, and all of the exterior or outside angles will also add up to 360 degrees. When we're focusing on a very particular quadrilateral, like a parallelogram, there are separate angle relationships or angle theorems to take into consideration. All adjacent angles or angles that are beside each other inside a parallelogram, they will be supplementary, meaning that they add up to 180 degrees. Lastly, opposite angles inside a parallelogram will be equal to each other. So angles that are in opposite corners of the parallelogram will have the same angle measurement.